Yes. It is. Yeah, we're gonna talk about it today. Next Thursday. Yeah, I'm not very on it. All right, it's 1 o'clock. Let's go ahead and get started. All right, good afternoon, everyone. How's everyone doing today? Good to hear. Okay. So week 10. So we are just about to make a transition in this class, and so today will actually be the last, I guess, real day of economics content in this class. And so we're going to finish up the inflation notes, and that's all I really have for economics. And so, between today and the midterm next Thursday, we're going to be doing a combination of a few things. And so on Thursday, what I have is Thursday's kind of a fun day. And so, I think at this point in the semester, everyone's kind of, we're all pretty tired, we're all pretty stressed at this point. So I thought, Thursday would be a good chance to do something a bit fun. And so what I have is a workshop based on entrepreneurship. So this is a workshop that I've gotten from one of our colleagues in the business school. His name's Atul Tekshandani. And so he's given this workshop in this class before a few times, but I've seen it 3 times now. So I am confident I can run it myself. And so we'll do that Thursday. So Thursday's just for fun. And so, if you want to kind of, have a bit of fun, learn a bit about entrepreneurship, there's that. But I also know you guys are really busy with stuff nowadays too. So, that can be, your 1-day break from this class too. And so, no, I won't take any offense to that at all. So, just want to let you know beforehand what Thursday is going to be about. Next Tuesday, we're going to start our first lecture on engineering ethics, which is, the other part of this course. And so next Tuesday, we'll kind of introduce what ethics is all about and why we study it and, how that ties into engineering. And then next Thursday is going to be our midterm. Okay, so midterm exam 2, next Thursday, November 3rd. And so the format will be very similar to the first midterm. And so I'm going to post a study guide. I meant to post it today before the class, but I kind of got caught up in some stuff. But I do have some free time after this, so I'm gonna get the study guide up after class today. I'll send an email to everyone just to let everyone know, just so that you can use it to study. Okay? And just like the first midterm, you're allowed to have a single 8.5 by 11 sheet of notes. You can use both sides. You can write it, type it, whatever you want. And I also plan to do a review video on Monday. Okay. And so, very similar to the first exam. You can bring your calculator, writing utensil, cheat sheet. That's all you can bring, and it will take place in person next Thursday. So please plan to be here in person next Thursday to take the exam, because there's no plans to offer it virtual, just like the first. Okay. All right, so we're going to be in a bit of a transitional period in this class. We're going to be wrapping up economics, transitioning to something new, taking exams. So next couple of weeks are going to be a little bit, we're going to be jumping all over the place with it. So I wanted to prime you guys a little bit before we start. Okay. All right, and so besides that, we're going to finish up our inflation lecture notes today. And so I think we stopped right in the middle of an example last time, and so we'll pick up that one, and then we'll finish up the rest of it. All right. Remember, homework 5 is out right now. So homework 5 is based on, I think I gave you a couple more tax problems because I know those can be a bit challenging. There's a couple problems on replacement, and then I think just 1 or 2 problems on inflation. So basically, I covered the rest of everything here. And it's going to be due next Tuesday. So a week from today, same time as usual, 11:59. Okay. All right. So that's all my announcements. Are there any questions I can answer before we get started for today? Okay. All right. So let's go ahead and get started. And actually, let me go ahead and swap back to the last week's lecture notes, so I don't have to write up this whole example again. Okay. And so when we left off last week, we've been covering this this idea of inflation, where inflation covers the fact, or it governs the fact that generally over time, the prices for goods, for services, for materials, it's all going to go up. Okay. And so we've been introducing, we kind of left off on this discussion of the different types of ways that we can quantify inflation. We can quantify the different dollars. And so we have this concept of actual dollars versus real dollars. Okay. And so remember, actual dollars, that's actual, physical money that you can use to exchange stuff. Whereas real dollars are meant to express it's supposed to represent purchasing power. Okay? And we went over these 4 rules, okay, in terms of how you can convert between those. Because remember, we have different interest rates as well, because we have our market interest rate, we have the real interest rate, and the inflation rate. Okay. And so what this kind of table here does, it connects all those concepts together, and it tells you how to convert between them, when to use which rate. Okay. And we're in the middle of doing this example here. So I know that was kind of a very quick overview, but I think once we start doing the example, it'll make things a bit more clear. And so if you remember from last Thursday, this example was that we have this sports stadium. And the last time the sports stadium was completed was in 1965, and the cost at the time was $1.2 million. Okay. And so at the time, the owner knew that the stadium's not going to last forever. And so what he said was that he wants to invest a lot of his money now in order to build the stadium's replacement. Okay, so he had kind of a lot of spare money, and actually an extra $1.2 million, and he's going to invest it at a market rate of 8%. Okay. And what we're also given in this problem is that the inflation rate is 6%. So each year, in between 1965 and 2020, which is when he plans to rebuild the stadium, prices for everything is going to go up by 6% each year. Okay, but at the same time, his investment is going to grow by 8% each year. And so what he's hoping for is that because the market rate is higher than inflation, then the gains that he's getting from the investment are going to outpace inflation. Okay. All right, and so this was a three-part problem. And so in part A, since we're given the market rate and since we're given the interest rate, we have everything that we need to compute the real interest rate. Okay, and so that was part A. Part B is to compute the actual worth of the investment if it was withdrawn in 2020, and so that's actual dollars. And then part C, which is the part we haven't done yet, is to compute the real worth of the investment. Okay. Okay. And so starting with part A, to compute the real interest rate, we're going to use our formula there. And so the real interest rate is just the difference between the market rate and inflation. So we have I minus F, and then we divide by 1 plus the inflation rate. Okay, so I minus F or 1 plus F. And so you compute that and you get a real interest rate of 1.887%. Okay. All right. And remember what the real interest rate represents. And so what the real interest rate represents is how much buying power that the owner is getting from that investment each year. Okay. So this represents 1.887% increase in buying power each year. Okay. Right. Because his money itself is growing at 8%, that's the market rate, but inflation is only 6%. So each year, the investment is growing a bit faster than inflation, and that growth rate is 1.887%. Okay. Okay, and so in part B, what it's asking us to compute is the actual worth of the investment if it was withdrawn in 2020. Okay. And so what we want to compute here is an actual to actual conversion, right? Because in 1965, he actually invested $1.2 million. And so that was actual money that he had. And then that money is going to grow at an 8% rate. Okay. And so since we're doing an actual to actual conversion here, then the rate that we're going to use here is the market rate. Okay. And so the market rate here is 8%. And so to compute the actual worth of the investment, we're going to do 1.2 million multiplied by an F over P factor and 8% for 55 years. Okay. And so if you look up that value in the table, and what you get is $82,701,600. Okay. Right. And so what that means is that, let's say that this wealthy owner here, deposited that $1.2 million into a bank account in 1965. Okay. He goes to the bank in 2020 and he asks the teller, how much is in that account. The teller is going to tell you, you have an actual $82 million in that. Okay. Okay. And then finally, we are in part C. So part C asks us to compute the real worth of the investment in 2020 in terms of 1965 purchasing power. Okay. All right, and so the key here is that we're looking for a real worth of the investment, and so we're computing of real dollars. Okay, so there's actually a couple ways that you can do this, and so you can actually use if we go back to the 4 rules from above, you can actually use either rule 2 or rule 3. Okay. All right, so I'll show you rule 2 first, because that's kind of the most straightforward. And so using rule 2, we want the real worth of an investment in 2020, which is of course 55 years in the future, based on 1965 purchasing power. And so this is a conversion between the real dollars to real dollars. Okay. So with the same basis. Okay. And so our basis here is 1965. Okay. Okay. And so we know that from the rules that if we're converting between real and real, we're going to use the real interest rate. Okay. And so the real interest rate we computed in part A, excuse me. And so that's 1.887%. And so the conversion here is going to be F is equal to 1.2 million times F over P, 1.887%, and 55 years. Okay. Okay. Of course, this is something that you're going to have to use the formula for, because there's no compound interest table for 1.887%. Okay. And if it's F over P, it's pretty simple. So it's just 1 plus I raised to the n power. Okay. Where n here is 55 and I is 0.01887. Okay. And so we compute all those numbers. What we get is $3,357,000. Okay. And so you might be asking, what does this number here represent? Because, we computed the actual amount that he's withdrawn. Okay. But that's different than this one. And so remember, whenever we're talking about real dollars, we're talking about purchasing power in some degree. Okay. And so what this is telling us that this investment, if he were to kind of use this back in 1965, he would be able to buy a stadium worth this much money back in 1965. Okay. And so think about it like this. And so the original stadium cost about $1.2 million back in 1965. Okay. And so, let's just say for the sake of argument that gives you a stadium with 10,000 seats. Okay, so 1.2 million for 10,000 seat stadium. Okay. And I know it's not like this because, it's structurally, it's a lot more difficult to add seats to a stadium. But, if we were to assume that relationship was still linear, then if he were to take this investment and put it back in time, he would be able to buy a stadium that's about 3 times as nice as the original. Okay. Because that investment is growing each year, and the rate at which it's growing is faster than inflation. Okay. And so what this here represents is that this new stadium will be about 3 times nicer than the old one. Okay? Okay, so this stadium, maybe it holds up to 30,000 seats if the original one held 10,000. Okay. So I'm spending a bit of time, emphasizing this because I think kind of understanding what real dollars represents can be a bit tough. Okay, because remember, whenever you're talking about real dollars, it has to have a time base associated with it. Otherwise, it doesn't make any sense. Okay. And so remember, the time base for this real dollars here is back in 1965. And so this is purchasing power back then. And so that's taking into account how much everything costs back then compared to now, where now things are just a lot more expensive. Okay. All right, any questions on this? Okay. All right, so that's how you solve part C with rule 2, but you can actually solve it with rule 3 as well. And so this is the part that I think this is the rule that confuses people the most. Okay. All right, and so if we read rule 3 is when we're converting between is a way to convert between actual dollars and real dollars. Okay. Right, and so rule 3 lets us convert between actual dollars being evaluated at some time n, and real dollars evaluated at that same time, but the time base is t. Okay. And so here n is going to be 2020 because that's when we're pulling out the investment, right? And so that's time in the future. And so T is when the real dollars are based in, which is 1965. Okay, that's gonna be our value of T. And so if we do N minus T, this is going to give us 55 years. Okay. And what we know from rule 3 is that if we have this situation, then the rate that we're going to use here is the inflation rate. Okay. And in this case, since we're kind of going back in time, and so we have actual dollars in 2020, which was given by part B. Okay. Since we're going back in time, we kind of have to strip away layers of inflation. Okay. Okay, so what does that look like? And so if we take our actual the actual amount of our investment, which was $82 million, so 82,701,600. Okay. And so what we're going to do is we're going to, that's the actual money in the future. We're going to transport that back into the past, but we're going to use the inflation rate. Okay. And so we have P over F. Our interest rate here is 6%, which in this case is the inflation rate, 55. Okay. Let's remember what this 82 million represents. This is the actual dollars in 2020. Okay. And so if we do this conversion right here, what we get is $3,357,000. Okay. All right, so compare this result to what we got from rule 3, okay? And you'll see that they're identical. And so either rule 2 or rule 3 will work here, right? And so, in practice, you only really have to do one way. Usually you don't get extra points to do things multiple ways, but it's always a good way to kind of check your results. For a problem like this, I just want to show you that there's kind of multiple approaches to it. And so you can kind of do more than one way, whichever works the easiest for you. Okay. All right, any questions on this? Yeah.
How did you know the inflation rate is 6%?
It was given in the problem. And so if we go to the problem right here, it says the inflation rate is 6%. Yeah. Mm-hmm. Okay, and so that hopefully that example makes things a bit more clear in terms of what's the difference between actual and real dollars. Okay. Let's do one more example, and actually let me go ahead and switch to week 10, just so my notes stay organized. Okay. Let's do one more example where we're actually going to work with actual and real dollars in the context of a comparison. Okay. Remember, we did a lot of these, back with present worth analysis and annual cash flow. And so, of course, when you factor inflation in, that's going to be something that affects these calculations. Okay. All right. So in this example problem here, let's say that you work for a company and you need to contract with another company to get to do some work for a project. Okay. Okay. And so this is a multi-year contract. And so, what your job is to kind of analyze the costs and benefits of each one over a 5-year period. Okay. Okay. And so through a lot of market research, you've narrowed the possible companies down to 2. Okay. Okay. And so the first company is called Alpha Company. Okay. Okay. And so what Alpha Company says is that their cost will be 150,000 actual dollars. Okay. But this amount will be increased by 5% each year. Okay. And so the actual money that you would pay to Alpha Company would increase by 5% each year. Okay. Okay. Next, we have Beta Company. And so Beta Company says our costs Beta Company's cost would be $150,000. Okay. But this is in terms of real dollars in today's time basis. Okay. Okay. So those are our two options. Okay, and so we're going to assume that these two companies are going to be contracted for 5 years. Okay, and so that's the amount of time. Okay. Okay, we're going to assume an interest rate. This is the market rate. Okay, and so we assume a market rate of 25% and an inflation rate of 3.5%. Okay. What we want to do is compute the present worths of both of these options. And we're going to do it in terms of actual dollars and real dollars. Okay. Okay. And the real dollars, just like the beta company, will be based on today's time basis. Okay. All right, so we have two companies here, and so just like we always do with present worth analysis, or in this case it is present worth analysis or annual cash flow. We have to make a choice, and so we have to choose which company here is going to be the most economically efficient for the company, assuming that both companies can do the job equally well. Okay. The problem with this example here, compared to past ones, is that the two companies have given us their costs, but they're in different forms. So one is going to give you the actual cost, but then the second one is going to be in terms of purchasing power. Okay. And so, we want to be able to do a fair comparison between these two. And so before we compute the present worth, we need to convert either one, we either need to convert both of them to actual or both of them to real. Okay. Okay. Any questions on this? Okay. All right. And so let's do, we're gonna do kind of both ways. And so first, let's do the analysis in actual dollars. Okay. And so what I'm going to do is this. And so let's make a table. Okay. And so let's list the cost for each year. Okay. And so we know Alpha Company, the cost is going to be $150,000 of actual money. Okay. But then we also know that this is going to increase by 5% each year. And so if we increase this by 5%, this is going to be 157,500, then 165,000, 375, 173,644. And then 182,326. Okay. All right, and so the differences between each of those is due to the fact that Alpha Company said it's going to increase its prices by 5% each year. Okay. This is different than the inflation rate, and so the inflation rate, the 3.5% that I gave you there, that's the general rate of inflation in terms of how general goods in general will rise up. Okay. Alpha Company is a bit different than that. Okay. Okay. All right, so Beta Company. So Beta Company tells us that the costs are $150,000 in terms of today's purchasing power. Okay. And so that's $150,000 worth of stuff. Okay. And so going back to our analogy from before, or our other example with the golf balls, let's say that this gives us 1,000 golf balls. Okay. So that's like what? $150 per golf ball. Let's do 10,000 golf balls. Maybe more reasonable, $15. Okay. And so what that means is that if we were to convert this $150,000 to actual dollars, we have in different time periods, we have to inflate it, right? Okay. Right. So since we know that generally in general, prices are going to go up by 3.5% each year, what that means is that each year, in order to get the same amount of stuff, the same number of golf balls, you have to pay more. In fact, you have to pay 3.5% more each year. Okay. And so to convert the actual dollars cost of Beta Company, we're going to do $150,000 multiplied by the inflation rate, which is 1.035. And we're going to raise it to the year that we're in. Okay. And so in year one, this is going to be $150,000 times 1.035. Okay. Because from today until the end of year one, then the prices for company B or Beta Company is going to increase by 3.5%. Okay, so that's what that represents. Okay. In the second year, we're going to have $150,000 times 1.035 squared. Okay, because inflation has applied twice because 2 years have passed since today. And we're going to repeat this for every year after that. Okay. So in year three is going to be times 1.035 cubed. And then so on and so forth. Okay. So each year, that $150,000 from Beta Company is going to be inflated by the rate of inflation. Okay. Okay, and so if we compute that amount, and so just to make sure I don't erase anything, let me go ahead and write the amounts down here. Okay. And so what I'll say that what I'm going to write below here is just the same thing as above, but just computed. Okay. Okay, and so in year one, we have 150,000 times 1.035, and so that's 155, 250, okay. Then 160, 284, 166, 308, 172, 128, 178, 153. Okay. And this is all for Beta Company. All right, and so now that we have the year-by-year breakdown for each alpha and beta, we can compute their net present worth. Okay. And in this case, since we're only considering costs, we haven't brought any revenue into the equation here. Then the superior option is going to be the one with the lower cost. Okay. Okay, so let's go ahead and set up the equations. All right, so let's do the present worth of the alpha company. So present worth of alpha company, we have 150,000. Okay. We know this is taking place at the end of year 1, and so this is going to be P over F. Okay. Since this is an actual dollar amount, and we're computing the actual present worth, then we use rule 1 here. And so actual to actual, we use the market rate. Okay. Okay. And this is just 1 year in the future. Okay. We're doing each of these as individual P over F's because there's no, it's hard to fit a gradient to this because the amount is changing by a percentage each year. And so it's a lot easier to do P over F conversions. Okay. Okay. All right, so that's our equation. And so of course, luckily 25% is in the compound interest table. So you can look these rates up, or conversion rates. And so what we get from this is $436,000. Okay. All right, and so then we can repeat the same thing for beta company, although I'm not gonna write out everything again, just because it's going to be more of the same. Remember that we've already converted beta company's cost to actual dollars, and so you're free to use the market rate here. Okay, and so if we do the same thing, or I should say same conversions, what we end up with is $441,000. Okay. Okay. And so based on this analysis here, we can see that alpha company is coming in a little bit cheaper. And so $5,000 more of present worth, or excuse me, 5,000 less cost in terms of present worth. And so what we should go for here is alpha company. Okay. Okay. All right, so that's an example of how you can do this analysis in actual dollars. Okay. And so if you're going to be doing the whole thing in actual dollars, then you need to make sure that you convert any real dollar amounts to actual dollars using the inflation rate, just like we did in this part. All right, any questions on how we did this part of the example here? Okay. All right, and so let's do the same example, but let's do it in terms of real dollars now. Okay. And so if we're going to do this analysis in real dollars, then we need to convert alpha company's costs into real dollars based on today's purchasing power. Okay. Okay. So doing the problem in this way is very similar to the first example we did today, where we had an actual dollar amount from the investment, but if we were to transport that back in time, in terms of real purchasing power, then we would need to strip away inflation from those years. Okay. Okay. Let's do this. And so let's go ahead and make another table. First thing I'm going to do is I'm going to write down the actual costs. Okay, so remember the actual costs for Alpha Company are going up by 5% each year. So I'm going to get $150,000. Okay. So those are the actual costs for Alpha Company in each of those years. Okay. But in order to convert this to real dollars, we need to strip away the years of inflation. But these inflated prices here, they already include, the fact that we're inflating by 3% each year. Okay. And so to account for this, instead of multiplying by the inflation rate, we're going to divide by it. And so we're going to divide, let's say year one here. So we're going to divide by 1.035 raised to the first power. Okay. And so we're going to divide by 1.035 raised to the power of the year that we're in. Okay. All right, because remember, we're taking this back into purchasing power for today's time. Okay. And so if we were going to say that this cost is going to be, 173,644 4 years from now, and so if we want to see, how if that's how much money that this is going to cost 4 years in the future, we want to see how much of what's the value of the stuff that we can buy today in terms of today's purchasing power. And so the way we do that is we divide by the inflation rate. Okay. All right. And so if we perform these arithmetic here, we get this amount. Okay. And so those are the yearly costs for Alpha Company. Okay. In terms of real purchasing power. Okay. Okay. And for Beta Company, we don't have to do any conversion here because Beta Company was already in terms of today's purchasing power. Okay. And so we're gonna have $150,000 each year. All right. And so now that we have the cash flow, so now both of these are in real dollars. Okay. Since they're both in real dollars, we can convert them to present worth. Okay. Okay. And so, of course, since we're converting real dollars into a real present worth, then we're going to use the real interest rate, okay? Which we weren't given in this problem. And so let's make sure to compute it. Okay. So the real interest rate here is the market rate minus the inflation rate divided by 1 plus the inflation rate. Okay. And so if you perform that calculation, you're going to get a real interest rate of 20.8%. Okay. Okay, so I'm not going to write out the entire conversion expressions here because I'm pretty sure you guys can do present worth calculations now. But if we were to do convert these to present worth using the interest rate of 20.8%, okay. What we get for Alpha Company is $436,000. And for Beta Company, you get $441,000. Okay. And so we get the same conclusion here. And so when we do this analysis in real dollars, we see that Alpha Company is still going to be the superior one because it has $5,000 less cost. Okay. All right, any questions on this? Okay. All right, one last point I want to make with this example, and then kind of the reason why I did this is to, let's compare our results for the present worths when we did actual dollars and real dollars. And so if we look at our present worth in actual dollars, okay, then let's scroll down to the real dollars, and let's go back up to the actual dollars, okay? You'll see we got the exact same result. And so, the present worth in both actual and real dollars is the same for both of these companies, okay? And so you might be saying, why did we go through the trouble of finding both? Well, just like anything that we teach in a classroom, there is an educational opportunity with this, okay? Remember rule 3 from our table, okay? And so when you're comparing actual dollars at a certain time point with real dollars at the same time point with the same time basis, and so all the times are the same, then those two represent the same thing, okay? Meaning that this present worth that we computed in actual dollars, this is an actual cost of contracting Alpha Company, okay? So $436,000, okay? That $436,000 also represents a certain amount of purchasing power in today's time. Okay? How much purchasing power? $436,000. Okay? And so when you're talking about actual dollars and purchasing power in the same time period, those two are exactly the same because the actual dollar, like $20 today, will get you $20 worth of stuff today because that's the same thing. Okay, so cash, when you're considering actual money and purchasing power or real dollars in the same time period with the same time basis, you're going to get the exact same result. Okay, and so this example hopefully will illustrate that. Okay. And this is rule 3. Okay. All right, any questions on this? Okay, all right, so one last concept I want to go over with inflation, and this is probably the most interesting and probably the most useful, is this idea of price indices. Okay. Okay. And so throughout this whole chapter, we've talked about how inflation represents how much more expensive or the increase in cost, in goods year to year. Okay. If you listen to the news, you'll hear that they'll probably quote just a general inflation rate. And so when they say inflation is 8%, what that means that on average across all goods and all services, prices have increased 8% compared to last year. Okay. That kind of oversimplifies things a little bit because certain industries or certain types of goods will inflate at different rates than others. Okay. Okay. And so we see this every day. And so I was just talking with a coworker today too that tracking gas prices have been kind of a fun but also not so fun thing as well. And so I was just telling someone that I filled up gas last night. I wasn't exactly empty, but I saw gas was under $6. And I was like, that's a pretty good price to fill up gas nowadays. And so I should take advantage of this before it jumps up by $1 again next week, which could happen. And so you gotta ride the good prices when they're here. You don't know how long they're gonna last, right? All right, and so the official way that we kind of as a country or as an economy we keep track of prices is through these things called price indices. And so this is actually tracked, and this is actually researched by the government. And it's actually published in a report every single year. Okay. Okay. But I think the way that they're reported is a little bit, it's not as straightforward as you might think, because usually when we think of inflation, especially for this chapter, we've been considering inflation as a percentage, right? And so inflation 8%, that means prices are going to grow by 8%. Okay? If you look at price indices, they don't give you a percentage, they actually give you a number, and it's actually a 3-digit number. Okay? And so the way it works like this, and so the way price indices work is that they basically have a way to track how much prices go from year to year. And so what you start with is kind of like a starting price. Okay. And so let's say that the starting price is just whatever the cost was at the beginning of the year. Okay. Okay. And so that starting price is given like a base index or a starting price index of 100. Okay. Okay. right? So 100 representing kind of, 100% or, 100 points of the cost. Right? Over the course of a year, and so, from that starting point, and let's say that we fast forward a year, the price of that good is going to change. Okay? Most of the time it's going to increase, but you can also have decreases as well. Okay. And so in a year, usually it's a year, but you can also have price indices for a short amount of time. Okay. Okay. And so let's say that we're computing the price index. Okay. And so the price index is often given the symbol LCI, and so the CI stands for cost index. Okay. And then the cost index at time n is going to be whatever the cost of that good is, usually averaged over the entire country, over an entire area. Okay. At the time n, divided by the base cost, or the starting cost, I should say, multiplied by 100. Okay. Okay. And so it still kind of is a percentage, just they don't put a percentage there. And so it's basically, what the price is, basically a ratio, whatever the price is now compared to where it started at, multiplied by 100 to get kind of a nice whole number. Okay. Right. So I'll just give you a quick example. And so let's say that the price of eggs have raised 35% over the past year. And so its price index, or its LCI, is going to be 135. Okay. Because it's 35% more expensive. And so if you take the ratio of the price now compared to what it was before, you get 1.35. Okay. And then you multiply that by 100 and you get 135. Okay. Okay. And so every year the government puts out a report in terms of, what it's kind of reporting as inflation. Okay. And so as one of the conceptual problems in the homework, I think I asked you to look it up for the current year. And so it should be out for this year already. And so, it'll be a fascinating read for sure. Okay. You'll see a lot of data in that table because they literally track, the prices of almost every single good, and they kind of have subcategories. And so under food, they have like meats, vegetables, eggs, stuff like that. Okay. And so looking at that report and seeing, how much inflation has happened in different sections, I think will be very interesting, very depressing, but very interesting. I haven't actually looked at the report this year yet, and so I'll probably look at it, sometime before the next homework is due. Okay. But check it out. I think it's interesting to see, and especially because this is information that is put out on a regular basis. There's a lot of data in there, so it's not reported on a lot, but it's really interesting to see how the prices of things have changed over the many years. Okay. All right. Any questions on price indices? Okay, all right, so that's about it. And so, that's all that I have for inflation. And so, you should be equipped to do everything in homework 5. And this is going to be the cutoff point too. And so homework, or excuse me, midterm 2, this is the cutoff point. So anything after this is just going to either be ethics or just going to be fun stuff. Okay, and so on Thursday, remember Thursday, what I have planned is an entrepreneurship workshop. And so, you can attend it virtually for that as well. But if you want the full experience, you can come in person. But remember, it's kind of just for fun thing, I kind of want to give you guys a break in this class just because we've been doing like lots of, heavy numbers and heavy calculations for a while. And so Thursday will be kind of a fun activity, but it's worth your time. I'd say it's fun. And then Tuesday, we'll start talking about ethics, and next Thursday will be the midterm. And so thank you guys for coming today. If you have questions on the homework or anything, or you have questions on the midterm, you're free to send me an email or ask me a question in office hours or after class. I hope you guys enjoy the rest of your day, and I will see you on Thursday. Zoom people, any final questions? There's quite a few guys left. Okay. All right. So if there's no questions from Zoom, I'm going to go ahead and close it up. And so I'll see you guys on Thursday.